This wrist-mounted crossbow uses 3D printed parts to shoot empty pen cartridges. It straps onto the forearm and works through a repeating mechanism, meaning it can fire several shots in a row without needing to reload each time. To make it work, you print the pieces, fit them together, and add some elastic bands or springs for tension. The whole thing is triggered by a quick motion of the hand, making it feel a bit like something out of a movie. Once set up, the crossbow fires smoothly. The printed parts fit together well, and the moving sections do what they're supposed to. You can also print extra pieces to use as ammo if you don't want to use actual pen cartridges. Everything you need, design files and instructions, is available online. Most people with a basic 3D printer can make it. There are other models out there too. One has a trigger you can press with one hand and a place to hold spare projectiles. Another fires when you flick your wrist and looks like something from a video game. Compared to those, this design is simpler. Some users make small changes to get a better fit or to fine-tune how it shoots. Even though it's made for fun, it still fires with enough force that you shouldn't aim it at anyone's face. A custom vehicle like this isn't something you see every day. At the heart of it is a modified Packard engine, known for its strength and strong pulling power. But instead of using the usual parts, the builder paired it with Volkswagen carburetors. To handle that power, the builder used a Chevrolet transmission. It's a popular choice because it's reliable and fits well with many setups. The result is smooth gear shifting and dependable performance. For steering, parts from both Packard and Ford were combined. It may sound odd, but it gives the car sharp. The suspension is just as creative. The springs were taken from a trailer, not your typical car part, but they were chosen for their strength. The wheels are 21 inches tall, giving the vehicle a taller look and helping it stand out even more. What really makes this car different is the way it was built. It's not trying to copy a classic or restore an old car. It's something completely original, made by putting together parts that weren't meant to fit. The body is especially unique. Part of it was shaped using pieces from a canoe. This gives the car a look more like a boat than a regular road vehicle. In a world where most bikes look the same, this custom motorcycle is different. It was pulled from a scrap pile and rebuilt from the ground up. Now it runs perfectly, mixing tough looks with smart engineering. Its standout feature is a reworked exhaust. It doesn't just help the bike move, it also blows loose dirt off the road as you ride. That clears the path, and during races, shoots a dramatic dust trail behind the bike. It's unusual, but it's useful too. There are fun extras as well. Built-in speakers for music, and laser lights that outline the bike with glowing shapes. The lights give the bike a look you won't forget. Every part seems adjusted for a reason, so it feels like a complete build, not just a cosmetic makeover. The style leans futuristic, almost insect-like, with sharp angles and neon accents. It looks like something from a sci-fi movie, yet it's real and ready for the road. The bold shape makes it hard to copy. Even though one person built it, the mechanics work the way they should. There's no sign of cut corners, even without big company support or fancy workshops. The builder used common tools, skill, and a clear plan. This buggy took 4 years to build and now runs with a 600 cubic centimeter engine. It uses a custom 4x4 setup so all 4 wheels can drive when needed, likely with parts that let the axles lock for tougher terrain. The frame is made from tubes of steel to stay strong off-road while keeping the weight balanced. From the test clips, the suspension looks custom too. Some parts work independently, and others use a solid axle, with home-built arms to suit the terrain. Steering is a simple, manual rack with direct linkages, and it likely has hydraulic disc brakes on all 4 wheels, powered by a master cylinder taken from another vehicle. Big, knobby tires help it grip during climbs and controlled slides. A time-lapse video shows the whole journey from bare metal to a working machine. You see the frame being welded, the engine and gearbox going in, careful alignment, suspension tests, and finally the body panels being fitted. The quick cuts make it easy to follow how the design evolved, with lots of trial, error, and improvements along the way. Built by GJ Powersports, the Buggy appears alongside their other projects on YouTube, Facebook, and TikTok. Clips show it tackling dirt tracks, jumps, and slopes, which give a clear feel for its power and control in real conditions. A backyard roller coaster uses a 3.5-inch air-powered launcher to push a one-person cart from 0 to fast in just a few seconds. It can deliver over 1,200 pounds of force. The track is made from wood with plastic tubing for the rails, held up by wooden supports. The cart is bare bones. 1 seat, a seat belt, no padding, and no fancy controls. Just enough to keep the rider in place when the air kicks in. There are no hills or drops to build speed. Instead, a sudden burst of air pressure fires the cart forward. The track is short, so the ride ends quickly, but those few seconds are intense. The first shove is sharp and surprising, and before you fully registered it, the ride is already wrapping up. The feeling sticks with you. One person built this from scratch at home, not in a regulated workshop. The design chooses raw speed and sensation over comfort or looks. It may appear simple, but what it does is anything but. There are no formal safety systems, so every part has to do its job. People who try it don't forget it. The sudden speed, the jolt your body feels, and the stripped-down setup add up to a rare and intense experience. This little go-kart runs on 2 Makita tool batteries wired together to make 36 volts. They feed a 24-volt motor taken from a mobility scooter. Speed is controlled by a foot pedal tied into the scooter's original hand throttle, plus a simple dash knob that limits speed from 1 to 10. Top speed is about 10 to 12 miles per hour, depending on the rider's weight. The frame is built from rescued parts. The back half comes from a wheelbarrow. The front and the bracing use bicycle tubing and metal from an old lawn chair. Sleeves inside the tubes strengthen the joints, and diagonal braces under the chassis keep the frame stiff. The motor and transaxle sit in a custom cradle. It pivots on bearings made from bicycle wheel hubs and square tubing. Coil springs connect this cradle to the main frame, so bumps and axle movement get soaked up instead of shaking the whole cart. Up front, a piece of steel channel is shaped and welded into a dropped axle, then smoothed. The spindle mounts and plates set the wheels with 8 degrees of caster and a 5-degree kingpin angle to help it track straight and feel stable. The front suspension uses 12mm pillow block bearings that slide inside square tubing, matched with 60-pound coil springs. Steering follows Ackerman geometry, so the tires don't scrub in turns. The steering arms are cut from flat steel, and the tie rods are made from 1/2-inch conduit with threaded nuts and heim joints. A conduit steering column turns a wheel made from a welded bicycle handlebar attached to a sprocket hub. This electric jet surfboard can reach speeds of about 34 miles per hour. It's powered by a brushless motor that produces around 10 to 12 kilowatts, and it runs on a strong lithium battery pack similar to those used in drones, but on a larger scale. The battery delivers between 44 and 52 volts and has a capacity of 40 ampere hours. To keep the motor cool, water is circulated through a cooling system built into the jet stream. The surfboard's propulsion comes from a specially built jet pump with a 3D printed or machined impeller. Riders control the speed with a waterproof wireless throttle, much like a remote control system. Altogether, the setup weighs about 35 to 40 kilograms. With continuous riding, it lasts 8 to 12 minutes and usually takes around 2 hours to recharge. Unlike a traditional surfboard, this one doesn't depend on waves or wind. Its motor and electronics are sealed inside the board, which measures about 1.8 to 2 meters long and 60 centimeters wide. The shape is designed to give stability on the water. The body is built from fiberglass layered over foam, with carbon fiber reinforcing key areas. Everything is sealed with marine epoxy, so water can't leak inside. The battery and electronics are arranged in a central bay, which makes them easier to access and keeps them protected. Safety features like fuses and circuits are included to prevent electrical problems. The system is designed more for short bursts of high speed than for long rides. The Furphy Wheel slowly turns food over an open fire using the power of moving water. A small water wheel sits in a creek or a diverted stream and is linked to a horizontal spit above the fire. One end of the spit connects to the wheel. The other end is secured for balance. It turns at a steady, gentle pace. No electricity and no hand cranking needed, so the food cooks evenly over time. The setup runs quietly on its own, using only the flow of water and gravity. Because the movement is smooth and consistent, it keeps the food rotating without someone standing there to watch it. The idea borrows from old water-powered tools and applies the same simple engineering to cooking. The name comes from the Furphy water cart, a big iron water tank on cast iron wheels made in Australia in the late 1800s. People used to swap stories around those carts, and Furphy became slang for a rumor. The modern cooker isn't the same thing, but it uses the name to nod to that history of water-powered ingenuity. You'll find the Furphy Wheel at Faucet Farm Homestead in northern Tasmania. The farm hosts cooking workshops, grows its own produce, and serves slow-cooked meals over open flames. Guests can explore the gardens, pick ingredients, and stay in small, comfortable cabins. In that setting, the Furphy Wheel isn't a gimmick. It's a quiet, practical tool that fits naturally into everyday farm life, turning steadily while dinner cooks. This vehicle was inspired by NASA's Mars rovers, and it is built with 6 powered wheels, a rocker bogie suspension, and an Arduino control system. Every part looks like it was custom made and put together with precision, giving the whole structure a clean look. The suspension uses the same style found in real planetary rovers, which helps it stay balanced and move smoothly over bumps or obstacles. Each of the 6 wheels has its own motor, giving power and allowing them to react individually to the ground. The front and back pairs of wheels can turn, which makes steering tight and effective, even on rough terrain. Power comes from 6 large batteries, each rated at 8,000 mAh, adding up to 48,000 mAh in total. This means the vehicle can run for long stretches without needing frequent recharging. An Arduino board inside the electronics box controls the steering and movement, keeping everything coordinated. The project was created by Chris Temmerman for his child. It's not just a simple toy, but more like a miniature off-road vehicle. Control is managed through a wired remote, allowing a parent to stay in charge while still giving the child an exciting riding experience. For safety, a sidebar is placed next to the seat to help keep the rider secure. This small aircraft is built for one person. It has a wingspan of about 17 feet and a length of just less than 13 feet. The wings cover 62 square feet, and the plane itself weighs around 375 pounds when empty. Fully loaded, it can take off at up to 750 pounds, which leaves room for the pilot, fuel, and baggage. Engines are usually modified Volkswagen car engines, producing between 36 and 80 horsepower. Fuel tanks hold between 8 and 30 gallons, giving it a cruising speed close to 180 miles per hour and a maximum speed of about 200 miles per hour. Depending on fuel, it can fly up to 1,400 miles. The climb rate is between 800 and 1,200 feet per minute, and it stalls at speeds between 42 and 52 miles per hour. It can reach altitudes of around 15,000 feet and needs about 300 to 350 feet of runway for takeoff and 600 to 900 feet to land. The aircraft first appeared in the United States in the early 1970s. It has a low wing design with an enclosed cockpit and tailwheel landing gear. Some versions include retractable wheels, but many builders prefer fixed wheels, either in tail dragger or tricycle style. The wings are supported by two spars, the front made of spruce wood and the rear a mix of spruce and plywood. The wing ribs are foam, and the outside is covered with fabric coated in epoxy. To make transport easier, parts of the wings beyond the landing gear can be removed. The body of the plane uses a wooden frame. The lower part is covered with plywood, while the top is shaped from foam and then wrapped in fabric. One of the advantages of this design is that no welding or special machining is needed. It can be built with normal workshop tools in about 1,000 hours. It looks like water is pouring forever from a faucet that floats in mid-air, but it's actually a clever setup. Inside the faucet there's a clear, acrylic tube, about 20 millimeters wide and roughly 20 inches long. Near the top of the tube, several small holes are drilled so the water can spread out in a smooth ring. The tube slides snugly into the faucet and connects at the bottom to a small submersible pump that runs on a 12-volt DC power supply. The pump's wires are soldered to a DC jack and covered with heat shrink tubing so everything stays safe. The pump sits at the bottom of a metal bucket or any waterproof container. A small hole at the back of the container gives the power cord a hidden way out. The faucet and tube stand upright over the pump's outlet and are fixed in place. Epoxy holds the tube inside the faucet and hot glue secures the lower joint. A bit of extra glue seals the cord's exit before you add water. When you switch it on, the pump sends water up through the clear tube. The water flows out through the tiny holes and forms a smooth sheet that wraps around the tube. Because the tube is transparent and covered by moving water, you don't notice it, so the faucet looks like it's pouring from thin air. Even spacing of the holes keeps the flow steady. The glue stops parts from shifting, and the stones both stabilize the setup and make it look nicer. A hammock pergola is basically a solid wood frame that holds a comfy hanging spot to relax. You start with 4 sturdy 6x6 posts, each about 10 feet long. Dig holes nearly 24 inches deep and 18 inches wide. Set the posts in place and pour in 2 to 3 bags of 50-pound concrete per hole so everything stays put. Long 2x8 boards run across the tops of the posts as beams, and many people cut the beam ends at an angle for a cleaner look. Rafters or slats go on top, spaced about 12 to 24 inches apart, and you fasten them with heavy-duty deck screws that are 8 to 10 inches long. For extra strength, you can add 2x6 cross braces. Most finished pergolas end up about 10 to 12 feet wide and deep, and 8 to 10 feet tall. That size lets a standard hammock hang nicely, with the posts set about 10 to 12 feet apart. For a bigger hammock, stretch the distance to around 14 feet. Hang your hammock from points about 4 to 5 feet off the ground, so it gets the right, gentle sag. When the woodwork is done, brush on an exterior grade stain or sealant to protect it from rain, sun, and seasonal wear. Once built, the pergola looks great in a garden, on a patio, or in any backyard spot, and it gives you a solid frame for everyday lounging. This amphibious vehicle is built on a strong steel frame with a hand-laid fiberglass body. It's 66 inches tall, 76 inches wide, and 181 inches long, with about 12 inches of ground clearance. It weighs around 2,950 pounds. All four wheels have disc brakes, and the long travel independent suspension helps it handle bumps and different terrains smoothly. Its size gives it a solid presence on the road and good stability on the water. Power comes from a 3.7-litre V6 engine that makes about 305 horsepower. Most versions are rear-wheel drive and can reach close to 80 miles per hour on land. On the water, the same engine drives a jet system that can get up to about 45 miles per hour. When you go afloat, steering switches from the steering wheel to a hydraulic marine setup so you keep precise control. Changing from road to water mode takes roughly 15 seconds. You pull up near the launch point, shift to neutral, retract the wheels, and engage the marine drive. The hull is shaped to lift smoothly and reduce drag, so it glides efficiently across the water. Inside, there's seating for 4 with water-resistant upholstery and sealed flooring. You get analog marine gauges and a dashboard with toggles and switches made for wet environments. You can also request extras like upgraded materials, audio systems, and custom controls. This trike sits very low to the ground and has a look that makes it stand out. It's designed in the style of cars that are lowered and stanced, giving it a bold, custom appearance. The frame has been reinforced and modified to hold 2 rear wheels on a single axle. You can see the welding and changes made to strengthen it. The rear axle looks like a steel crossbar, likely reinforced so the twin wheels can stay balanced. The wheels are noticeably different in size. At the back, the wide, deep dish wheels dominate the frame, giving the trike a flared, aggressive look. The front wheel, on the other hand, is slim. The trike is so low that it almost scrapes the ground, which helps keep the center of gravity stable, but doesn't leave much room for suspension movement. The seat is positioned very close to the frame. It looks like a small scooter seat, or even a bucket-style seat, chosen more for the way it fits the design than for rider comfort. There's little sign of cushioning or back support, so it's not built for long rides. The drivetrain isn't fully visible, but it may use a basic pedal and chain system. If it does work, the chain would need to be rerouted to fit the lowered frame and 3-wheel setup. On the other hand, the trike may just be a showpiece, meant to look impressive in photos and videos rather than serve as a practical ride. Automatik designed a 3-wheeled, pedal-plus electric vehicle for city use. It has a smooth, mostly closed body, but the top is open so the rider's head sticks out. That open top makes it easier to see and keeps air flowing, even though it won't block rain or cold, as well as a fully closed design. It can reach about 50 kilometers per hour, which is impressive for a home-built project. You pedal, and an electric motor helps. With 3 wheels, the ride is stable, especially at higher speeds or on bumpy streets. The whole build cost roughly $500, and about $170 of that went to powder coating the outside. That suggests the body is steel or another metal. The vehicle sits low and has a streamlined shape to cut through the air. Like many Velomobiles, it follows a recumbent trike layout. You sit reclined inside a protective shell. This shape can reduce wind drag a lot, sometimes by 10% to 60% compared with bikes without a shell. There are no doors and no full cover over the upper body. That choice favors clear vision and simpler construction rather than full weather protection. People in Brest see it often, used for daily trips and commuting. Right from the start, this project grabs attention as a clever way to solve problems with simple mechanics. The vehicle is small, built in the style of a tank, and made completely from scrap metal. Its frame is put together with steel tubes and sheet metal, strong enough to work, but still compact enough to fit in a garage. The drivetrain and transmission use recycled parts, with gears and pulleys adapted into a working system. The tracks are made from linked metal pieces or old conveyor material, supported by tension wheels and a basic suspension. The project developed step by step, shared in detailed video updates. Each video showed a new stage: building the frame, adjusting the suspension, putting the drive system together, and fine-tuning the steering. Instead of showing off a finished machine, the creator focused on testing, experimenting, and learning along the way. This wasn't a product for sale or military use, but a personal project to explore engineering challenges. Its real value comes from the careful documentation, showing how all the parts come together to form a working tracked vehicle. By the end, the creator reflected on possible future improvements, keeping the project open for growth. The idea came from a lone inventor in Poland who used whatever tools and parts were on hand. The goal was to build something that works. It reflects a growing do-it-yourself trend, turning scrap and simple engineering into useful equipment. A small sawmill with a 4.5 kilowatt motor. The blade moves through big logs, so it's a good fit for small workshops, local milling, or making lumber on a limited scale. The saw carriage rolls on a track using simple gate casters, the kind of wheels used on sliding garden gates. This makes the movement smooth and easy to control, and it works without any special parts. Most of the frame and rails were built from parts the maker already had in the garage. The only new items were the caster wheels, which were ordered online. The result is a practical sawmill, and it's simple enough for others to copy with basic tools and skills. In early tests, it cut full-size logs cleanly. The cuts were steady, with no wobble or shaking. The track kept the saw straight from end to end, which helped keep long boards accurate. It's not as fast as factory machines, but the speed is perfectly fine for a small setup. A garage elevator with a 1.4 horsepower motor makes it easy to lift heavy things into ceiling storage. It can rise up to 550 pounds, so you can safely send up toolboxes, holiday boxes, and storage bins. If the power goes out, or something isn't right, an emergency brake locks the platform so nothing falls. This idea solves a common problem. Floor space is tight, but the ceiling has room that's hard to reach. Ladders and overloaded shelves are risky, and in this garage, the ceiling beams weren't meant to hold heavy, non-stop weight. Instead of pushing the structure past its limits, the elevator spreads the weight over time as it moves. The setup looks simple, but is planned well. The motor lifts at a steady pace, and the frame keeps the load balanced while it goes up and down. Only basic alignment and spacing were needed in the ceiling, so the lift fits into the garage without major changes. What also stands out is how it was built. A homeowner and his son worked on it together. They mixed mechanical know-how with practical problem solving to make something that fits their needs. Next one is a helicopter built in Hungary, and it follows strict European aviation rules, proving it safe for more than just casual flying. Its main rotor spans 23 feet, giving it the lift it needs for steady and controlled flight. Its engine building it gives the owner a clear view of how every part works together, which makes maintenance easier and deepens the pilot's confidence while operating it. In use, the aircraft is practical for tasks like monitoring forests, farmland, or rough terrain where roads can't reach. It can also play a role in emergencies, reaching remote areas quickly. From land surveys and environmental studies to checking infrastructure in hard-to-reach places, it helps cover large areas with speed and efficiency. It began as a daring idea. Build a drivable copy of a Lamborghini Aventador with a large 3D printer. The team calls it the Interceptor. It blends design with hands-on garage work to show how 3D printing can make complex car body parts. Every outside panel, from the front bumper to the rear and the side scoops, was printed in sections. Each piece was tweaked and reprinted, with photos showing how the fit and finish improved over time. Under the printed body sits a custom steel frame. The frame, suspension, and drivetrain are all steel to give the car real strength for the road. This isn't a movie prop or a showroom dummy. It's built to be driven. Inside, there's a usable cabin. The dashboard is 3D printed, likely adapted from open source files. Everything is hooked up, so the car responds to the driver, not just to look good in pictures. The builder has a background in physics and military service, and shares the process to help others learn about engineering and manufacturing. There aren't official performance numbers yet, but every part is made with real-world driving in mind. The car keeps improving through testing and tinkering, showing how complex machines can grow from a mix of digital design and practical mechanical skill. This flying system uses a Life-N engine, which is a copy of the Honda GX640. It makes 17 horsepower, enough to lift off and cruise under ultralight rules. With the gearbox, exhaust, and propeller, the whole setup weighs less than 105 pounds, so it's light and easy to move without special gear. The design is a Paratrike. Think of a three-wheeled cart with the motor in back and a big paraglider wing above. For takeoff, the wing fills with air and creates lift. The pilot sits in the frame and steers by pulling hand lines and shifting body weight. Using the throttle changes speed and altitude. It keeps things simple with basic mechanical parts instead of lots of electronics. Alexander Mazov in Russia built this to be practical, only what's needed to fly. The base model is about $650 for the frame and the power unit. You still need to buy the wing and safety gear, but even then, the total cost is usually lower than many similar aircraft. In some countries, including the United States, ultralights like this have very light regulations, so you don't need a pilot's license. That doesn't mean skipping safety. Proper training, understanding weather, and regular maintenance are essential. Mistakes or failures close to the ground can still be dangerous. The machine towers over people at more than 11 feet tall and weighs nearly 2,200 pounds. At first glance, it looks like a giant humanoid robot, but instead of walking, it actually moves on hidden wheels inside its feet. These wheels let it roll forward slowly, about 1 mile per hour, which creates the illusion of a heavy, shuffling step. Inside, there's a cockpit designed like a small airplane cabin. It fits a single operator, who controls the robot with levers and screens. These controls move the arms and start the rolling motion. The robot's body is supported by a strong metal frame that carries its massive weight while still allowing the arms to move. Each arm is equipped with air-powered cannon that shoot rubber or plastic balls. This gives the performance a sense of action and excitement without being dangerous. When it was first introduced in the mid-2000s, this robot was among the earliest real-life attempts to bring popular culture's dream of rideable mechs into reality. Later models would become bigger and more advanced, but this one remains special as an early step in turning imagination into a working machine. Hexapod walks using 12 Dynamixel servos. 6 are in the lower legs to move them up and down. The other 6 sit at the shoulders and are dual axis, so each one can lift the leg and swing it side to side. Together, each leg gets full 3-axis control, which makes the robot's movement coordinated. The body, links, and joints were designed in Fusion 360, and then 3D printed. At the center is a control board with a 32-bit Cortex M3. It works with the Arduino IDE. The inverse kinematics code is written in C++ and runs directly on this board. A handheld controller, based on an Arduino Duo, sends the remote commands. Everything started in software before any printing. A full inverse kinematics simulation let the team test and tweak how the legs moved in a virtual model. That way, they improved timing and coordination without risking parts or wasting material. Only after the simulation behaved reliably did they move on to the physical build. The workflow was simple and logical. Simulate first, design second, assemble last. Using dual-function shoulder servos reduced mechanical complexity by putting 2 motions in one unit. Old rubber is getting a second life thanks to smart uses. When old tires are processed and mixed into concrete, they make it tougher and more flexible. This helps the concrete absorb stress and resist cracks, which is especially useful in earthquake zones. Using tire rubber also means we need fewer new raw materials, which can lower costs. At home, people are getting creative with used tires. One popular project is a tire table. Take a clean tire, add a glass top, and even put lights inside for a cool industrial look. Others stack and paint tires to make raised garden planters, build small pet shelters using tire pieces and wood, or create water features by layering tires to guide the flow. More than 1 billion tires are thrown away every year. Left alone, they break down very slowly and can collect stagnant water, which becomes a health risk. By turning them into building materials, fuel, or useful items for the home and garden, we get more value from something that would otherwise be trash. A wooden frame surrounds the Epiphone guitar, but it isn't just any frame. The wood has been treated with shusugi-ban, an old Japanese method where the surface is burned, brushed, and sealed to bring out its grain. Traditionally, this was done with a chimney packed with straw, but here a blowtorch was used instead, giving more precision. The result is wood that looks dark and textured, catching light in soft, shifting ways. It stands out, but without taking attention away from the guitar inside. The case is softly lit, so the guitar becomes the center of focus. The glow highlights the shape of the instrument and the signatures on it. It isn't overdone. The lighting feels balanced, turning the case into more than storage. It becomes a stage that respects the guitar's story. The guitar itself carries weight because of the signatures. Linkin Park, a band that shaped rock in the early 2000s, turned the Epiphone into something more than an instrument. It's now a piece of memory and culture. By placing it in a carefully crafted frame, the maker gave that memory a home, both physically and symbolically. Next homemade project, crush a can in just 2 seconds. It runs on a normal household power supply, so there's no need for special equipment. The process is simple. Place the can, press the button, and it's crushed. With this setup, the machine can process up to 1,800 cans per hour, making it very practical for anyone with lots of recyclables. You do need to load each can by hand, but because the cycle is so fast, it doesn't feel too repetitive. This setup saves both time and space when managing aluminum waste, which makes it especially useful in garages, workshops, or small businesses. What makes this crusher stand out is how much it can do without needing advanced technology. By reducing the size of cans before transporting them, it helps cut down on trips to recycling centers. That means less fuel use and easier storage. For those who like to customize, it's possible to add a feeder or hopper to make it semi-automatic. Still, even in its basic form, it works smoothly and delivers consistent results. Building it with parts you already have can also be cheaper than buying commercial alternatives with similar performance. The story behind this excavator matters too. One person started with an idea, and without company backing, or a big team built a serious piece of equipment. In a world full of mass-produced machines, this is a clear example of what persistence and practical skill can achieve. It is small enough to ride on a regular car trailer, but it still has the power to dig about 6 feet deep. It uses a simple hydraulic setup that handles hard, rocky soil. Over 3 years of real work on different ground, it hasn't had any major breakdowns. It was built in a home garage over 2 years. The maker mixed parts from older machines with custom pieces they fabricated themselves. There wasn't a strict blueprint, just lots of testing, fixing, and improving. The result is a machine that shows careful choices and hands-on know-how. Plenty of similar machines are sold, but many are pricey or need special transport. This one proves it doesn't have to be that way. It fits on a basic trailer and moves without special permits. Its performance on real jobs shows useful equipment doesn't need a big brand name. Next project idea comes from a home build using salvaged parts. Like a motor from a power tool and simple mechanical pieces to drive the plunger. There's no fancy automation or screen, but the mechanics fit the job well. Easy to build, easy to use, and steady at crushing cans. The crusher runs on a small DC motor. A belt and chain carry the motor's spin to a plunger. Gears slow the spin, so the push is stronger, turning the spinning motion into a straight, hard shove. That shove squashes a can down to roughly 1/3 or 1/4 of its original height. You control it by hand, likely with a push button or a toggle switch. A simple forward/reverse option can help start the crush and then reset it. You slide a can into a slot or small chamber, press the control, and the plunger come down to flatten it. When it's done, a spring or the reversed motor lifts the plunger back up, ready for the next can. The whole unit is roughly 16.5 inches deep, 3.5 inches wide, and 3.8 inches high, and it weighs around 7 pounds. The team in Denmark built this tracked vehicle over 10 weeks for a technical program. They didn't use a kit or step-by-step manual. They started from scratch, planned the system, found parts, made what they couldn't buy, welded, bolted, and tweaked along the way. No factory machines, just hands-on building. It runs on a tiny engine, about 3 cubic inches, that still packs a punch. The tracked design and sturdy frame let it climb steep hills and roll over rough ground without trouble. It's small but stable, built with clear, practical choices. Even without fancy materials or a high-end workshop, the machine runs reliably. The tidy build and smooth motion show they thought carefully about where forces go, how the weight is spread, and how the gears drive the tracks. The goal was to test ideas, fix mistakes, and learn by doing. Under tight deadlines, they delivered a machine that works as planned. Projects like this are becoming more common in Denmark, where small teams and students build real hardware in workshops and training spaces, not just in labs. Sometimes the coolest machines aren't built in big factories. They're put together by someone with a clear idea and good hands. This one is a mix of parts that have been reworked to fit together and actually get things done. Up front, it has a removable dozer blade that can push dirt, snow, or mulch. It rides on heavy-duty tracks that once came from a military-style all-terrain vehicle. Those tracks were pulled from a junkyard, rebuilt, and fitted to this machine, giving it great grip. The cabin is closed in to keep the weather out, and the seats are cushy, like what you'd find in a modern side-by-side. There's room for more than one person, so it's useful and also fun to share. It's smaller than a full-size construction rig, which makes it easier to steer, park, and haul around. Even so, it can pull, push, and climb much better than you'd expect for its size. Its look hints at tanks and sci-fi rovers, but what really matters is how well it works. The blade lifts and drops smoothly, and the tracks keep it moving steadily over different surfaces. Inside, the driver stays comfortable and in control. The compact size is perfect for personal projects where tight turns and easy handling matter, yet it still performs like a bigger machine. You can see the care in every part. The welds, bolts, and small tweaks were done with purpose, so the whole thing feels balanced and solid. Watching it run, clearing a path or chewing through deep snow, you get both power and a sense of fun. It's a smart blend of muscle, design, and hands-on creativity, making a machine that's truly its own thing. This backyard railway stretches for more than 1,148 feet on track laid by hand. A wood-fired steam engine, based on 19th century trains, makes about 5 horsepower, can pull several cars, and reaches up to 15 miles per hour. One engineer, Pavel Chilin, built everything from raw materials, rails, boiler, and all, without using any pre-made parts. He shaped the metal by hand, leveled the ground, aligned the rails, and put the whole system together over more than 10 years. It might look playful at first, but it runs on real mechanics. Steam pressure drives the engine. It sits low to the ground, yet works like a small industrial machine. The track design includes 7 working switches, so the train can take different routes and change direction. In short, it's a small railway that's mechanically complete. Chilin also uses it for practical jobs around his property. The train hauls materials, handles regular loads, and keeps running in different weather without constant tweaks. People outside his area have taken notice because of the project's detail, size, and the years of steady effort behind it. Unlike many modern builds that rely on kits or computer models, this one came together through hands-on work and clear mechanical know-how. This 3-wheeled e-bike uses a 1 kilowatt geared motor and a 15 amp hour battery. It runs quietly and gives steady power, which makes it handy for daily city rides. You can still pedal it like a normal bike, or switch to electric help when you want. The 3 wheels add side-to-side stability, so it feels more secure on bumpy streets or at low speeds. Compared to old-style trikes, the frame is smaller and cleaner, so it looks more modern without losing usefulness. The whole project was built by one person in Hungary. He comes from a design background, not engineering. Working solo, he spent 2 months finding the parts and materials, then did the assembly and testing himself. The finished bike balances practicality with good looks and taps into the growing interest in new ways to get around. This idea took shape while cycling in Hungary was booming. During the pandemic, many people avoided public transport and turned to bikes instead. When spring arrived, bike sales went up by about 35%. In a country that usually sells around 300,000 bikes a year, that's a noticeable jump. The three-wheeler fits right into that moment. It's quiet, stable, and compact. Exactly the kind of mix cities need as travel habits change. People outside Hungary have noticed too, with interest coming from places like Sweden and Brazil. You can make a tiny food processor with a small electric motor, a plastic bottle cap, a battery pack, and a few wires. The motor sits in the bottle cap, and the cap screws onto a regular glass jar to make the base. Blades, reused from old gadgets or cut from stiff plastic, attached to the motor shaft. Turn it on, and the blades spin fast enough to puree soft fruit, mix ingredients, or chop herbs. It's not as strong as a fancy blender, but it handles simple jobs well. The fun part is how it uses everyday stuff and a little creativity. A hot glue gun and a drill are usually all you need to put it together. Clear tutorials online walk you through the steps, so anyone with some patience can try it. In the end, you get a working tool made mostly from things that might have gone in the trash. This idea fits a growing trend. Making practical kitchen tools from what you already have. It encourages a hands-on mindset, fixing and building instead of always buying. Reusing jar lids and old electronics also helps reduce waste. There is a bit to learn, and that's okay. Trying, making mistakes, and tweaking the design build real skills. It also gives you confidence, not just in cooking, but in building and problem solving. This is a small, handmade skidder, a mini tractor built to pull logs through rough ground. It's made entirely from salvaged parts, yet it does jobs you'd expect from bigger factory machines. Because it's compact, it can squeeze down forest paths and into narrow clearings where full-size equipment can't go. Even though it looks modest, it moves steadily over bumps, loose soil, and steep hills while dragging heavy logs. The design is all about function. There aren't many electronics to worry about, which makes repairs simpler and fieldwork less stressful. The builder has several patents and a background in practical inventions, like heating systems and industrial tools. You can see that experience in how this machine works. It's built to deliver results with limited resources, using discarded parts that would otherwise go to waste. In 2017, engineers in the Netherlands built a 1-kilometer road using an unusual material: recycled toilet paper. At wastewater plants, tiny paper fibers called cellulose are filtered out, cleaned and processed. Those fibers are then mixed into road materials. The road looks and works like a normal one, but it starts with something that would have been thrown away. Dutch cities also use underground trash bins with sensors. The sensors check how full the bins are and send a message when they need to be emptied. The bins also have extra bag dispensers to keep the area tidy. Each container costs about $182 to install, but this setup cuts down on collection trips and helps prevent overflowing trash. The system for recovering cellulose works so well that the Netherlands exports some of the processed material to the United Kingdom. There, it's used to make biocomposites for different products. This is a clear example of a circular economy, turning waste back into useful materials. In 2024, the Netherlands led the European Union in recycling plastic packaging. That result didn't come from one or two projects. It came from steady rules, long-term planning, and people taking part by sorting and recycling their waste. The country's goal is bold, by 2050, to have a fully circular economy. That means all materials used should be renewable or fully reusable. Projects like the toilet paper road and the smart bins are practical steps toward that target. This gate combines metal, wood, and electronics in one unit. The frame uses welded steel and aluminum, while the hardwood panels are sealed with a marine-grade finish so they handle weather for years. You can choose the motor type, a 24-volt DC or a 230-volt AC induction motor, depending on the model. Power ranges from 370 to 550 watts. That's enough for gates up to 2,645 pounds and up to 39 feet long. It moves as fast as 39 feet per minute, and you can adjust the speed in the controller. Movement is driven by a rack and pinion system with either hardened steel or a nylon steel composite gear. A torque-limiting clutch helps it sense obstacles and avoid damage. The control board is computer-based and includes surge protection. It can take signals from remotes, keypads, and vehicle loop detectors, both wired and wireless. It can also send power to safety lights, alarms, and gate locks. With the optional Wi-Fi module, you can connect it to smart home platforms. Controls are simple: LED status lights, small DIP switches, or an LCD touch panel depending on the version. Safety features include 2 infrared sensors to watch for movement, automatic reverse if the gate touches something, a keyed manual release for power outages, and soft start/stop to reduce strain on parts. This piece takes parts from a Porsche 996 Carrera and turns those into a unique piece of furniture, most likely a sofa. It keeps the original car's size pretty closely, measuring around 14.5 feet long, nearly 6 feet wide, and just over a foot tall. The structure uses real car parts like seat frames and door panels, reinforced so it can safely hold 2 to 3 adults. The seating material is high-quality leather, similar to what you'd find inside the actual car. There are also some electrical features built in. Posts about the project mention things like xenon lights, which suggests it has some kind of built-in LED or ambient lighting inspired by the car's headlights. The wiring is likely hidden inside the frame, and the lighting probably runs on a safe 12-volt system. Even though it's called a hoverboard, it doesn't actually move or float. It's more of an art piece or conversation starter than a mode of transport. The project comes from a Spanish design studio called Bell & Bell. They specialize in turning old vehicle parts into interesting home items. Instead of letting these car parts go to waste, they've found a new way to use them while keeping their original character. It's a creative take on recycling, but done with care and a strong eye for design. The table works with a very simple idea. It attaches to the latch of a car's trunk. Once fixed, it becomes a stable surface that measures about 24 by 18 inches, just the right size for a stove, mugs, or a meal setup. Even though it folds down to only 4 inches thick, it can hold up to 33 pounds while weighing just 10 pounds itself. Setting it up takes about 10 seconds, and when folded, it stays neatly in the trunk without taking much space. It fits most cars, vans, and 4x4s, except for those with Automatik or soft close tailgates. Each table comes with a padded case, adapters for different vehicles, and clear instructions. In real use, people find it practical for many outdoor activities. It's solid enough for camping trips, long road journeys, tailgate gatherings, or festivals. It holds stoves firmly and gives a clean surface for food and drinks, even when the ground is wet. Since it folds flat, It fits easily with other gear in the trunk and is always ready to use without rearranging things. Thanks to its careful design and durable materials, it turns an ordinary car into a mini outdoor station for meals, gear, and quick breaks.